Today's topic is about integration. We are going to cover just the basic understanding of integration in this particular session. Integration is also called as integral calculus. What it does? Integration. Integration means joining, right? It is joining. It joins small parts together. What it does? It joins small parts together. In other words, integrates small parts to find sum total. This is the understanding about integration, and mostly we use integration for shapes and sizes which are not directly able to solve, right? For example, if you have a function which represents a graph like this, there is no direct formula to solve the area or to find a sum total of this particular function y is equal to fx. There is no direct formula, right? So what do we do in such a case? What do we do in such a case? Let us see in the next slate. I'll clear this slate. So we have a general function, and that general function is y is equal to function of x, is just a general function, and whose graph is given like this. This is x-axis, this is y, and this is function x. So let us find the area under the graph. So from here to here, let us find area under curve or graph from this point to this point. Let us say this point is x is equal to a and this point is x is equal to b. So basically from x is equal to a to x is equal to b, we want to find the total area. But we don't have any formula, no direct formula here. If you have, you can put it in the chat. There is no direct formula to find the area of this particular shape, right? But can we do one thing? Can we divide this into multiple small shapes? This is one shape, this is one shape, this is another shape. We divide it in such a way that the size of this shape, which is delta x, is tending to 0. It is very small. Okay, and this height here, let us say for this particular strip taken here, the first strip, okay, for the first strip where delta x tending to 0, the first strip is at a height yi. Okay, so if that is the case, then area for only this strip, which I marked it fully, area of only this strip will be given as ai will become equal to height yi into breadth, the height width, right, which is delta x. This is a triangle, no? Very closely, if it's a very small strip, it will almost become like a straight line here. The top will look like a straight line. That's why you can use this formula for triangle. Now if you have many such strips, right, we have many such small strips where x is tending to 0, delta x is tending to 0, then you can write total area is equal to a1 plus a2, right? This is a1, this is a1, for example, this is a2, and so on, right? You can write this finally as a summation from a to b of all the area of the rectangles. all the area of the rectangles, right? So what you'll do, y delta x, this is the area. Here x is tending to 0, right? It can give a better approximation if you tend x is equal to 0. If you tend x is equal to 0, what will happen? The graph will look like this. This is the graph. You're taking very small area, very small. Hence the entire graph will be covered. So like that, if you keep drawing the entire graph, all the lines very close to each other, small, delta x is tending to almost 0, right? As small as 0, you can take from A to B. So this can be represented as, I'll wipe this out. This summation, what we got? We got a summation, right? Summation of areas. How we read it? We got it as a summation of areas. A to B, summation of all the areas, y into delta x, right? This can be represented as integral because delta x is very small. So we can write the integration of a to b y dot dx, where dx is a variable from a to b. This sign here is called as the integral. Integral, or the sign for integration. Okay. Dx, what is dx called? Dx is called as the variable. Variable of what? Variable of integration. A is the lower limit. And B is the upper limit. Upper limit, lower limit of x and upper limit of x. So indirectly this can also be represented as from A to B, y is what? Y is a function of x itself dot dx, right? Basically this is called as the integral of function x or y with respect to x, and from limits a to b. And when the limits are defined, this is called as the definite integration. When the limits are defined, it is called as the definite integration. When the limits are not defined, this is when limits are defined. When the limits are not defined, and it is called as indefinite. Right? I'll just summarize it in my next slate. I'll clear this out. I'll clear this out. If you noted down this, well and good. I'll clear this out now. So if you have limits a to b of a function x with respect to dx, this is a definite integration. And if you have no limits, the limits are not defined, then this is called as indefinite. Right? And integration is basically an addition of small parts. Integrate small parts to find sum total. Small parts to find sum total. This is what we have learned in class. This is the summary of the whatever we have learned in the class. This is the summary. Okay, these two aspects is what we have learned, and this is the definition. So with this we close for integration. We are going to see what are the rules for integration in the next class. Okay, until then, see you. Bye.